Imagine hearing a perfect replica of your own voice, speaking words you never uttered. It's not a deep fake, it's the quiet revolution of AI voice cloning, now more accessible than ever. But how does this technology truly work, and can it really capture every nuance of human speech? We are on the cusp of an audio revolution, where digital voices are indistinguishable from human ones, and the power to create them is literally at your fingertips. Understanding this technology isn't just about curiosity, it's about unlocking incredible creative potential for content creators, businesses, and even individuals. From personalized audiobooks to hyper-realistic AI narrators for YouTube videos like this one, voice cloning is transforming how we interact with digital media. You might think it's science fiction, but the core principles are surprisingly logical, and the tools are already incredibly sophisticated. So let's unravel the fascinating process behind AI voice cloning, from the raw audio input to the synthesized speech that sounds eerily human. At its heart, AI voice cloning is the process of generating synthetic speech that mimics the unique characteristics of a specific human voice. It goes far beyond standard text-to-speech, which simply converts written text into generic spoken words. Voice cloning aims to capture the time, pitch, rhythm, accent, and even the subtle emotional inflections that make each human voice unique. The goal is not just to say the words, but to say them as you would. This capability is already being used to create custom voices for virtual assistants, develop unique characters for video games, and even help people with vocal disabilities retain a digital version of their own voice. But how do machines learn to do this? The journey begins with vast amounts of audio data. The first critical step in AI voice cloning is data collection and training. To clone a voice, an AI model needs to learn what that voice sounds like. This means feeding it hours, or sometimes just minutes, of high-quality speech from the target voice. Think of it like a child learning to mimic speech. They need to hear many examples before they can truly replicate it. These audio recordings must be clean, free from background noise, and ideally cover a wide range of phonemes, words, and sentences. The cleaner and more diverse the initial training data, the more accurate and natural the cloned voice will be. Each audio snippet is paired with a precise transcription of what was said. This combination of audio and text is fed into a sophisticated neural network, which then begins the process of deconstructing the voice. The AI isn't just memorizing sounds, it's analyzing the underlying patterns and features that define that specific voice. Next comes feature extraction. Once the AI has the raw audio, it begins to break down the complex waveform into more manageable digital components. Imagine taking a complex painting and analyzing it layer by layer. The brushstrokes, the colors, the lighting. Similarly, the AI extracts various acoustic features like pitch, tone, volume, and the spectral characteristics that give a voice its unique sound. These features are often represented visually as a spectrogram, which is a graph showing the intensity of different frequencies over time. This visual representation allows the neural network to identify and understand the intricate patterns that define a speaker's voice. It's like creating a unique sonic fingerprint for every individual. This detailed analysis allows the AI to distinguish between different speakers and even capture the nuances within a single speaker's vocal delivery. The magic truly happens within neural networks, especially those leveraging deep learning. These are complex computational models inspired by the human brain, designed to recognize patterns and make predictions. For voice cloning, specific architectures like encoder-decoder models are frequently used. The encoder part analyzes the input audio and text, compressing it into a rich, abstract representation, the voice's unique latent space. The decoder then takes this representation and synthesizes new audio, attempting to recreate the voice with new input text. Imagine the encoder learning the essence of a voice, and the decoder then using that essence to speak new words. Technologies like Tacotron and WaveNet have been foundational in this field. Tacotron helps convert text into a spectrogram, and WaveNet then takes that spectrogram and generates the raw audio waveform, making it sound incredibly natural. More recent innovations, like Google's VOLE, can even clone a voice from a mere 3-second audio sample, showcasing astonishing advancements in efficiency and fidelity. So, how can you put this powerful technology to use? The process for voice cloning with accessible tools is surprisingly straightforward. First, you'll need to choose a reputable AI voice cloning platform. There are several excellent options available, each with its own strengths and pricing models. Popular choices include ElevenLabs, Descript, Resemble.ai, and PlayHT. These platforms typically offer free tiers or trials, allowing you to experiment before committing. Each platform will guide you through its specific setup, but the core steps remain consistent. Once you've selected your platform, the next crucial step is recording your voice. To achieve the best results, aim for a clean audio environment, free from echoes or background noise. A good quality microphone can make a significant difference. Most platforms recommend recording at least 1 to 5 minutes of varied speech. This isn't just reading a single paragraph. It should include different words, sentences, and even some natural pauses and inflections. Some platforms perform better with more data, sometimes suggesting up to 30 minutes for truly robust clones. The more diverse and higher quality your audio samples, the better the AI can learn your unique vocal characteristics. After recording, you'll upload your audio files to the chosen platform. The AI model will then begin its training process. This can take anywhere from a few minutes to an hour, depending on the amount of data and the complexity of the model. During this phase, the AI is essentially building its voice fingerprint based on your provided samples. Once the training is complete, your cloned voice is ready for generation. You simply type in the text you want your AI voice to speak, and the platform's engine will synthesize the audio. Most tools allow you to make subtle adjustments to the output, such as controlling the speaking speed, adjusting the pitch slightly, or emphasizing certain words to fine-tune the emotional delivery. You can often generate multiple takes and choose the one that sounds most natural for your specific content. While AI voice cloning has come incredibly far, it's not without its challenges and ongoing developments. One major area of focus is capturing genuine emotional expression. While current models can mimic basic emotions, achieving the full spectrum of human feeling, the subtle shifts in tone that convey sarcasm, deep empathy, or complex joy remains a significant hurdle. Multilingual cloning, where a voice can speak fluently in multiple languages while retaining its unique identity, is another exciting frontier. Real-time cloning, enabling instantaneous voice synthesis, is also rapidly advancing, opening doors for live translation and dynamic virtual interactions. However, these advancements also bring serious ethical considerations. The potential for misuse, such as creating deepfakes for fraud, disinformation, or impersonation, is a critical concern. Many platforms are implementing safeguards, like watermarking AI-generated audio or requiring explicit consent from the original speaker. As users, it's vital to be aware of these implications and use the technology responsibly. There are several common mistakes that can prevent you from getting the best results with AI voice cloning. The first, and arguably most important, is using poor source audio quality. If your training data is filled with background noise, echoes, or inconsistent volume levels, the AI will learn these imperfections as part of your voice, leading to a synthetic output that sounds unnatural or distorted. Always prioritize a quiet environment and a good microphone. Another frequent error is providing insufficient training data. While some advanced models can work with very little, most benefit greatly from more varied and extensive samples. A minute of speech might give you a functional clone, but 10 or 20 minutes will yield a far more robust and natural-sounding digital voice that can handle a wider range of phrases and emotions. Neglecting ethical implications is also a significant pitfall. Using someone's voice without their explicit, informed consent is not only unethical, but potentially illegal. Always ensure you have the right to clone and use a voice, especially if it's not your own. Furthermore, expecting immediate perfection from a single take can lead to frustration. AI voice cloning, like any creative tool, often requires iteration and fine-tuning. Play with the settings, try different input texts, and experiment with the emotional controls available on your chosen platform to achieve the desired outcome. Finally, failing to proofread your input text can result in awkward pronunciations or incorrect emphasis. The AI will read exactly what you give it, so ensure your text is grammatically correct and punctuated appropriately to guide the AI's delivery. So, what should you do next? The best way to understand AI voice cloning is to experience it yourself. Explore the free tiers offered by platforms like ElevenLabs or Descript. Record a short sample of your own voice, upload it, and play around with generating new phrases. Listen critically to the results and experiment with the various settings. It's an empowering experience to hear your own digital twin speak. The future of audio is undeniably intertwined with AI. From creating personalized content to enhancing accessibility, the capabilities of voice cloning are only just beginning to unfold. Understanding its mechanisms empowers you to harness this technology responsibly and creatively. Stay curious. This is AI Unpacked.